This video will be a mini review of the main concepts that we have learned about parabolas. We will take a parabola equation and just plain graph it and list out the key information. We will come up with the equation of a parabola in standard form given the vertex and the directrix. And finally, we will take a general form equation of a parabola and use completing the square to convert this over to standard form, and once again we'll graph it and state the key information. When you are graphing a parabola equation, the first thing you should do is decide whether or not the parabola opens up, down, left, or right. We learned a long time ago that y equals x squared was the basic first parabola we ever learned about. So when you see x squared, you know it's going to be a vertical parabola, either up or down if there's a negative involved. But if you see something strange where the y is squared instead of the x, well, that's a weird sideways parabola, which will either be to the right or to the left if there's a negative involved. So looking at this problem, I see I have the y minus 4 squared. The y part is squared. When the y part is squared, that means it is a sideways parabola. It's either going to open left or right. Because the 12 is negative, that tells me it's going to open left. So this parabola will be opening to the left. And here's a little mini sketch of what's going to happen, a little thumbnail sketch. The parabola is going to open to the left. In the interior of the parabola, we will have the focus. And then off to the right, we will have the directrix. Okay, now let's make all that happen. So the next thing we want to do is figure out what the vertex is. Be very careful. The vertex is going to be the opposite of this and the opposite of this. However, you have to be careful about the order. This is not in the order that the vertex is going to be in. The reason why is because the x-coordinate of the vertex is going to come from the x part of the equation. So I'm going to do the opposite of this and get -1, but that's going to go here first. The x-coordinate of the vertex comes from the x part of the equation. The y-coordinate of the vertex will come from the y part of the equation, so I will do the opposite of this and put a +4. So the vertex is -1, 4, and I will graph that now. -1, 4, there's my vertex right there. Next, I need to find the focus. To do that, I'm going to recognize that this number in the front is 4p. So that means 4p equals -12. If I divide both sides by 4, I get p equals -3. The significance of that is the -3 tells me where to put the focus. I know that the focus is to the left of the vertex. The -3 tells me that it will be exactly 3 to the left. So 1, 2, 3. Boom, here's my focus. Immediately I will go ahead and draw my directrix, this vertical line. It will be exactly the same amount in the other direction. So if the focus is 3 to the left, the directrix will be 3 to the right. So the directrix will be a vertical line at 2. Go ahead and draw it as a dotted line. Okay, one more thing. The focal width. We will use the focal width to plot 2 additional points to complete this graph. The focal width is going to come from this number right here as well. Focal width. However, width has to be positive. So even though this is a -12, for the focal width, I'm going to put +12. Now, that will help me graph points because if I go over to the focus, I know that the parabola has to have a width of 12 over here. So that means if I go up 6, 1, 2, 3, 4, 5, 6, and down 6, 1, 2, 3, 4, 5, 6, this makes a total width of 12 at the focus. These 3 points are enough to show me where the parabola is, so I can go ahead and graph it. Okay, let's go and fill in the rest of this information. The focus is right here at -4, 4. The directrix is right here. A vertical line is always going to be x equals something. In this case, x equals 2. If it had been a horizontal line, I would have put y equals something. And we already did the focal width. So that is it for problem number 1. Okay, problem number 2. Write the equation of the parabola with vertex 2, -5 and directrix y equals 3. When I give you some information like this and I'm asking you to come up with an equation, the key is to make a diagram. So here's my y-axis and here is my x-axis. So the vertex is at 2, -5. So let's see. 1, 2, so this is 2, and 1, 2, 3, 4, 5. So this is -5. Okay, so here's my vertex at 2, -5. Now my directrix is y equals 3. Y equals 3 is a horizontal line at 3. Vertical lines are x equals, horizontal lines are y equals. So a horizontal line at 3. So here's 3. So my directrix will look like this. Show it as a dotted line. Okay. We know that the parabola has to open away from the vertex. The parabola has to open away from the directrix. So since the directrix is up here, the parabola must open in this direction. Okay. Now, because the parabola is facing down, it's vertical. So right away that tells me that we are dealing with the model of a parabola, the parabola formula, where the x will be squared. So I'm talking about x minus h squared is equal to 4p times y minus k, not squared. Alright, this is the version that we use for vertical parabolas. So anytime I see a vertical parabola, I will do the version with x squared. If it was sideways, if it was a horizontal parabola, I would my x's and y's would be reversed. So I'd have y minus k squared is equal to 4p times x minus h, not squared. This is for horizontal parabolas. Anyway, back to what we actually have. We know h and k because we know the vertex. So we can go ahead and fill that part of the equation in. So it's the opposite of this and the opposite of that. So it will be x minus 2 squared is equal to 4p times y plus 5. Okay? Make sure you don't just go in order. This time that was true. The 2 goes first and the -5 went second. But always pay attention to make sure that the x-coordinate of the vertex winds up in the x part of the equation. So all we need is the p value. For the p value, we need to look at the focus, which we have not plotted yet. So where would the focus be? So understand that the focus lives in the interior of the parabola. So it should be in here somewhere. But exactly where will it be? Well, it should be the same distance below the vertex that the directrix is above. Alright, the vertex should be right in the middle between the directrix and the focus. So let's see, how far apart are these? So maybe you will notice that this distance right here is 8. I can tell that without really counting because this is down 5, this is up 3, that's a distance of 8. So what I need to do is go a distance of 8 again, and that will be my focus. So let's go. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to put us at negative 13 if I go down 8 again. So boom. And again, just to be super clear, it's because this was 8, then this was also 8. However, the direction matters. Because this is down, okay, maybe I'll put it as an arrow instead. When I looked at the directrix was up 8. Alright, so that's positive 8 in that direction. But when I look towards the focus, I'm going down 8. That's why P is equal to negative 8. Okay, because it's down 8. Okay, so now we know the P value, so we can go ahead and finish this equation. So now we have x minus 2 squared is equal to 4 times negative 8 times y plus 5. So this is going to give me x minus 2 squared is equal to negative 32 times y plus 5, not squared. So this would be the standard form equation of the parabola that has vertex 2, negative 5 and directrix y equals 3. Alright, number 3 is the last problem in our mini review. We need to take this general form and transform it into standard form, similar to the equation that we wrote right here, and similar to the equation that we were given in problem number 1. Notice the parentheses that we have. In order to generate these parentheses, we're going to complete the square and factor. So, pay attention to which variable is squared. You want the squared variable to be on the left side of the equation. So I see that the y is squared. That means I want all of the y terms on the left side of the equation. The x is not squared anywhere. So that means I'm going to move the x term and any constant over to the right hand side, in this case by subtracting each of these. So if I do that, I'm going to have y squared minus 6y, and then I'm going to have equals negative 10x minus 9. Now I left a little space here in which to complete the square. Now completing the square, you do half the middle squared. So half of this is negative 3. If I square that, I get 9. So I'm going to have plus 9 here and here. So that allows me to factor. So this is going to factor as y minus 3 times y minus 3. Now this problem is going to be a little extra easy because these 9's cancel each other out completely, and that just leaves me with negative 10x. So this can be written as y minus 3 squared is equal to negative 10x. So this is my standard form equation. Okay, now I need to take this equation and graph it. So the first thing I need to do is decide, does this parabola open up, down, left, or right? Well, I see that y is squared. Whenever y is squared, it's going to be sideways. It will either open to the right or it will open to the left. Because this 10 is negative, I know it will actually open to the left. So here's my thumbnail sketch. I'm going to have a parabola opening to the left. In the interior of the parabola, there will be a focus, and then off to the right, there will be a directrix, a vertical line. Okay, so with that in mind, let's go ahead and start graphing. We need to start with the vertex. What is the vertex going to be? So the vertex is going to be the opposite of this, and there's no parentheses. So, when I look at problem number 1, I have the x plus 1, and this gave me a negative 1 because I do the opposite. When there are no parentheses and all you have is x, that means it's 0. It's sort of like I had x minus 0. But let's not write that down. So this part's going to be 0. Now be careful of the order. I'm going to do the opposite of this and 0, but not in that order. The x part of the equation gives me the x coordinate of the vertex. So it's the x value of the vertex that is 0. The y coordinate of the vertex will be the opposite of this, which will be positive 3. So the vertex is 0, 3, which is right here. There's my vertex. Now I need to graph the focus. To find the focus, I need the p-value. This number right here is equal to 4p. So that means 4p equals negative 10. If I divide both sides by 4, what am I going to get? Okay, this reduces down to negative 5 over 2, or as a decimal, this would be negative 2.5. So the p-value is negative 2.5. I know that my focus will be to the left of the vertex. Now I know that it will be negative 2.5. 2.5 to the left. So if I go 2.5 to the left, that tells me that my focus is right here. While I'm at it, the directrix should be the same distance in the opposite direction. So if I go 2.5 to the right, here is my directrix. Okay, I'm trying to draw this right down the middle, but it's tough. Okay, I need to plot 2 more points to graph this accurately. And for that, I will use my focal width. This negative 10 also tells me the focal width. The focal width is 10. Width is always positive. So even though this says negative 10, the focal width is positive 10. That means as my parabola opens here to the left, at the focus, the width is 10. That will help me graph because if I start at the focus and I go up 5, and I go down 5, this gives me a total width of 10. So that's the focal width. And these 3 points are enough for me to graph the parabola. Okay, and there it is. So let's see. The focus is at negative 2.5, comma 3. Okay, using decimals is risky because sometimes we have to approximate. What if it was 2.33333 or something like that? So I like to use fractions whenever possible. So remember that negative 2.5 was, it came from negative 5 halves. So this would be the same thing as negative 5 over 2, comma 3. The directrix is a vertical line at 2.5. So that's x equals 2.5, or x equals 5 over 2. The vertex is at 0, comma 3, as we found, and remember that the focal width was 10. So that's it for our little mini review of parabola concepts. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.